Hello, this is Sydney Hines, and this is my second article for air pollution in the news. The article that I chose is titled Innovations for Cleaner Futures, Emerging Technologies in Air Pollution Mitigation. Here are the authors, and here is the link that's provided. So I'm going to go over some of the clean energy technologies that the article highlights. So there's improvements in green energy would reduce air pollution and helping like alleviate the demand on fossil fuels and combustion of like coal and oil and natural gas and whatnot. So some of the improvements in green energy would include photovoltaic systems, concentrated solar power, wind turbines, both offshore and onshore, pump storage, hydropower. In case you don't know what that is, it's essentially where you pump water up to like a certain head, and then you let it fall down to a lower head, and there's a turbine in between, and it generates electricity. You can also integrate these green energy innovations into the power grid for energy storage, for like smart grids, basically being able to control like the demand, like the daily demand and yearly demand and all of that. Okay. Here's the transportation and mobility. So again, innovations in for electric vehicles. The battery, plug-in hybrid, and those are key to cutting tailpipe emissions because again, they have no emissions. Fuel cell vehicles. So like for example, I have a diagram of a hydrogen fuel cell electric vehicle off to the right. And again, there's no emissions in a hydrogen fuel cell vehicle other than say like water. Um, and that's pretty much it. There's also sustainable aviation as well. So eventually there'll be electric aircraft, which again don't have emissions. Next, the article also talks about green building and urban design. Um, so you can take existing buildings or you can build new buildings that have like these smart systems integrated into them. And I can talk about a few of them here. So energy efficient buildings. So passive strategies, insulation, high performance windows, to basically decrease the amount of energy that the building uses. So net zero energy buildings, right? So of course that would involve, integrating some green energy into the design. Okay, smart buildings. A lot of this will involve, networks of sensors working in tandem to control, like, the energy usage. So this will be automated control via the sensors I just mentioned. Internet of Things, building management systems to optimize energy, efficient ventilation systems and HVAC systems, and also waste reduction as well. Buildings, generate a lot of waste. Okay, if a large apartment building with several floors, that's going to generate a lot of waste. So maybe have like some type of recycling system in that. And speaking of recycling, green materials. So you can have low embodied energy, um, recycled content, low VOC products. So VOCs are volatile organic compounds, right? So again, if you say throw a water bottle or something in the grass, it's not going to break down or break down over a very long time. And it will release, chemicals, into the ground and it will get into like, groundwater. And, that leads to different pollution. Um, how, plastics can contribute to air pollution is if they're like combusted or something like that. Um, or if they end up being just left out to, like bake in the sun and degrade in the environment. And then, of course, those chemicals will be leached into the air. Nature-based infrastructure, so using like green roofs, vertical gardens, permeable surfaces. Vertical gardens can also be used to like clean the air because, plants sequester CO2. Um, Also to, improve air filtration as well. Reducing heat islands. A heat island is essentially, where you take like an infrared, I guess, sensor over like a city, and you realize it's extremely hot. Why? Because you have all that light that's that's reflecting off of those windows, right? So that's what we talked about, like the smart buildings and energy efficient buildings, right? So again, high performance windows and energy efficient windows are important for that. Letting in as much light as possible so that you use less lighting and you're using less electricity. It means that you're burning less fossil fuels. Okay. Next, we can talk about waste management and a circular economy. Um, talked about recycling before, but how exactly is that done, right? So waste to energy, so technologies like gasification, anaerobic digestion, um, pyrolysis convert waste into usable energy. Of course, that can be done by microorganisms, so bioremediation, right? Literally breaking down, like for example, that tossed water bottle example I gave earlier. You can use maybe some bacteria or some other microbe to break down that water bottle, and maybe even prevent the release of these VOCs. Um, some of them these microbes can also be used in the smokestack itself to sequester right some of the CO2, for example, because there are a lot of photosynthetic microbes out there like cyanobacteria, for example. And so, again, recycling, right? So these are closed loops of material flows to reduce demand for like the original resources and the emissions associated with disposing of those resources. Okay. Off to the right, I have an example of a waste to energy system. Okay, there, as you can see, there are multiple pathways, from like that, from the initial trash to electricity production to uh, to putting it in a landfill, which is not a good option. But there are alternatives, such as processing them and turning them into aggregates or something used for construction, or you know recycling them in back into metals. So there are many different paths, okay, for waste management. Okay, air quality monitoring and data analytics. So how do you know that you're reducing air pollution with these various emerging technologies? Well, remote sensing can be used. So there are multiple low-cost sensors that are available. You can use drones. You can use GIS, or geographical information systems, for spatial mapping of pollution hotspots to figure out where are the areas we need to focus on more. Use of big data. So there's a lot of AI and machine learning technology that's out there. You can use to predict, where where these like polluting patterns are, um, and say, hey, let's say there's like air quality or something on Tuesday is going to drop significantly. Well, that means that, well, I mean, how do you know that? Well, you know it because of those machine learning and algorithms. Okay. Citizen science and participatory sensing. So this is basically mobilizing communities to be more aware of of like their air quality, and and coming up with maybe like some more like local solutions to reducing air quality. So here's some of the challenges, some of those emerging technologies I mentioned. So there'd be barriers to adoption. Okay, there'll be again, these some of these are very expensive. Um, like I mentioned before, there are low cost sensors, yes, but let's say I want to put like a like a CO2 scrubber or something in a smokestack, that's going to be expensive. Let's say I want to introduce more battery electric vehicles or hydrogen electric or or fuel cell vehicles, hydrogen fuel cell vehicles into the market. That's incredibly expensive. Making manufacturing batteries and manufacturing fuel cells. Technological maturity gaps, difficulties in retrofitting or integrating new systems into existing infrastructure, regulatory permitting uncertainties, right? And I will, come down to like policies or policy levers. So, initiating emission standards, maybe subsidies for these different technologies and tax incentives and grants. For example, there used to be, I believe, a battery electric vehicle like tax incentive. A lot of those battery electric vehicle manufacturers are actually given subsidies by, I believe it was the Department of Energy as well. So equity and justice. So I guess that would be eliminating, you know, marginalized, oh, so the, not leaving marginalized communities behind and making sure that they benefit from cleaner air and these technologies as well. Um, Collaboration and capacity building. So public-private partnerships, basically um, companies and governments working together to reduce air pollution, training programs to scale these innovations. These are emerging technologies, so people need to be highly educated, highly skilled workers in order to build and to install and to maintain these technologies. Okay, some of the impressions from the article. So this article is a good survey of various emerging technologies that can reduce air pollution. Um, I would have liked to see like more real world examples of like specific companies and governments that were implementing policies in real time to to introduce these emerging technologies to the market. Okay. So in conclusion, so a multi-pronged approach is needed for mitigating air pollution. So by combining advances in clean energy, mobility, in vehicles and transportation, urban design, waste management, um, that's how you reduce air pollution. It's not just with one of these emerging technologies. They all need to work in tandem, and need to also have encouragement from the government and from local communities as well. So monitoring to reduce air pollution, um, and again, that supportive policy is needed. Okay, cross-sector collaboration is needed. That those public-private partnerships mentioned earlier, those are needed in order to realistically implement emerging technologies. Thank you.